Welcome. In this video, we're going to go over how to make a stem plot manually and using technology. A recent 24 student college level course at a local university had students with the ages given in the table below. Use the data to generate a stem and leaf plot both manually and using technology. And then here, the follow-up question. What does the stem and leaf plot tell you about the students in this course? Are there any outliers? The first thing you need to do is sort the data. And we can go ahead and rewrite all these 24 values, or we can just kind of sort it within our stem and leaf plot. And I'm going to tell you what I mean. So you want to start by drawing just a vertical line. And next to it, look at these numbers. I see numbers in the 30s, teens, 20s, more 30s. I see someone in their 50s. Okay, so I'm going to make sure my smallest values are for the teens and my largest is for the 50s. And I'm going to do that by writing 1, 2, 3, 4, 5. To represent a number like 22, you would put a 2 here. So that tells you this is 22. You can also represent the number, say, 43 and 47 by writing a 3 and a 7 here. So these first two values tell you that you have a number 43, and then these two tell you you have a number 47. Okay, so now that we have our scaffolding built, that is our 10s, 20s, 30s, 40s, and 50s, let's go ahead and find all the values in their teens. And I'm going to quickly just go through and highlight any value that has a 1 in the tens place. And this is just so I can get this stem and leaf plot done quickly. Okay, now of all these values that are highlighted, and because they are highlighted, it is really easy to see which is the smallest value and which is the largest. The smallest is 12 and the largest is 19. So let's go ahead and represent these numbers starting from the smallest here to the largest here. Additionally, leave even spacing between your numbers. You'll see why soon. So the smallest number is 12. So I will go ahead and write a 2 here. That means there's a student that is 12 in this college level course. That is very young. The next number, the next smallest number that is 17. And there are 1, 2 17s. So I'm going to write 7, 7. And notice I'm trying to leave about the same space between them. There we go, that's better. What's the next smallest number? Well, that's 18. 1, 2, 3 18-year-old students. So I'm going to write down 3 8s. And then finally, there are 1, 2, 3, 4 19-year-old students. Now we can move on to the 20s. So I'm going to grab a different color highlighter, blue, and go ahead and highlight any value that has a 2 in the tens place. And now I can easily see that the smallest value I have is 20, so 2, 0, and I have 1, 2, 3, 4 of those. So I'm going to go ahead and write a 0 here. 0, 0, 0. And if you notice, I'm purposely stacking numbers on top of each other. And that'll really help us see the student ages and where they lie. So what's next? Next would be the 21. It's just 1 larger than 20, and there are 2 of those. So I'm going to write 1, 1. Next is 22, and I only see 1 22 here. The next smallest number is 24, then 26, and 27. Finally, let's look at the last values. The 30s, I see someone who is 30 years old here. So that's 3, 0. I see someone who is 33, and then someone who is 35. Okay, and then the only one remaining is 58. So now that we're done, we can easily tell that the class is pretty evenly split between people in their teens and people in their 20s. Also, being older in this class doesn't seem very typical since there's only a few students in their 30s, no one in their 40s, and then there's this person here in their 50s, almost 60 in this class. To answer our last question, are there any outliers? Well, this makes it really easy to see that this student here, the student that's 58, may actually be an outlier. This class is definitely skewed towards younger ages, so here are the younger students, and here are the older students. Additionally, one problem that could come up is it really is atypical to be 12 years old in a college level course, but if you notice, that's kind of hidden here because we see all these numbers in their teens, and you might miss the fact that there's a very young student here. Now, even though this class is skewed younger, we can use what we know from real life, from our past experiences, to gauge that this is also likely an atypical student age, as is this atypical student age. This one is not so easy to see. This one is easy to see using the stem and leaf plot.